Moving along with our packet, we are now going to move into the topic of combinations. So a combination is a selection of objects, and the key word will be selection. So whenever we're talking about arrangements, that's permutations. A selection does not regard order. So you're just selecting any 10 objects from a group of 50, let's say. Anytime it's a straight selection, we're using what are called combinations. Now, I just want to compare the two concepts. So let's assume that once again we have 3 letters and we're selecting 2. Let's take a look at all the different permutations. So if you have 3 letters, all the different permutations, there will be 6. A, B, B, A, B, C, C, B, A, C, and C, A. So, and of course we've already learned about our formula, 3p2 is 6. Now, let's say that we don't care about the order. So in that situation, we're dealing with what are called combinations. They're basically groups. We're counting the number of groups of 2 that contain the same letters. So for combinations, we're going to treat AB as the same as BA. So there's one group of the letters AB. Another group would be AC or CA. And a third group would be BC or CB. Thus, when we're computing the combinations, there's only going to be 3 combinations. Whereas with permutations, there's 6, because AB is distinct from BA. Okay, so there is a formula that we'll be working with to compute combinations. However, once again, I'm just going to remind students that you do have a function on your calculator to compute these combinations. And I have videos that will show students how to actually utilize that function. So the formula is the following. It's somewhat similar to the permutation formula. There's one modification. Of course, we're not using P, we're using C for combinations. So N choose R. N is the total number of objects. R is the amount of selections. That's equal to n factorial divided by n minus r factorial times r factorial. So let's take a look at an example. Let's say that we have 5 cards, or we want to select 5 cards from a standard deck of cards. Well, it's a straight selection. When you see just the word selection, there's no order involved. Well, for our deck of cards, we have 52 cards. Let me just enlarge our formula here. There's 52 cards in our standard deck, and we're selecting 5. So to perform our calculations, we plug in for n 52 factorial divided by 52 minus 5 factorial times 5 factorial. And if we do these calculations correctly, we end up with the final answer of 2,598,960. So that is a total number of combinations when we select 5 cards from 52. Now, some problems will have more than one category. So this example just had one deck of cards. Let's look at another example. It says a car show has 4 Corvette Stingrays, 5 Ford Mustangs, and 3 Ferraris. If 5 cars are to be displayed without regard to order, determine how many displays are possible. 2 cars are Corvettes, 1 is a Mustang, and 2 are Ferraris. So the first step is we have to divide up our group into categories: Corvettes, Mustangs, Ferraris. For Corvettes, remember there's 4 Corvettes in total. We're only going to select 2 of them. So 4C2, let me enlarge this a bit. 4C2 is equal to 6. For the Mustangs, it says we're selecting 1 Mustang. And in total, we have 5 Mustangs to choose from. So that's 5C1 is 5. And finally, we compute the combinations for Ferraris. There's 3 to choose from, and we're selecting 2. So 3C2 is 3. Once we compute each of these values, we just multiply them together. And that's going to give us all the different combinations, or in this case, displays of cars without regard to order. So there's 90 such combinations. Now I would like you students to go ahead and finish these other examples. And then after that, I do have another page, and this page is copyrighted by Jessica Heitfeld. I was able to use or modify some of her problems. And basically these problems are just a review of the combinatoric rules. I just want to work out one of these problems because this problem is where students tend to run into some issues because of the wording. It's number 5. It says, how many ways can you make a 6-digit number without repetitions? So no repetitions are allowed. So be careful. Don't get confused. Don't start with 6. Remember, whenever you see the word digit, there's always 10 digits. So basically, we're just taking 10 and we're going to multiply 10, because there's 10 digits, with itself 6 times, because there's 6. It's 6 digit just means you have 6 locations, and digit means that there's always a choice of 10. So we multiply 10 with itself 6 times, and we get our final answer. The final answer is 1,000,000. So there's a million different 6-digit numbers that are possible. And so I would like you to finish this section. It's just a review, and then we'll move on to the last topic of this packet in the next video. Thank you.